All right, this video is going to take us through a few things about not only exponential rules, but also polynomials, how to work with them, that sort of thing. All right, so here we go. First things first is a somewhat complicated little problem here involving exponentials and their rules. So just really quick, I'm going to talk through it, but you can see it on your screen. You have the product rule, so a to the m times a to the n. You add the exponents. If you divide two things with the same base, you subtract them. A to the 1 is a to the 0 is 1, and that one's not going to play into this one. But anything raised to the negative 1 power is just 1 over itself. Likewise, if it's 1 over a to the negative 1, it flips and becomes a to the first. We also have any two things that are multiplied or raised to the common power, you distribute the power. We have division, which works the same way. You just distribute the power. And then you have a power to a power, and then you drop down and you multiply them. So multiplication leads to addition, division leads to subtraction, raising leads to multiplication. It tends to drop down 1 on your order of operations. All right, all of those are, well, not all of them, but many of them are likely to come into play. That being said, my students have watched me do a few of these and they're like, oh, you always flip them. You always flip them, right? I don't always flip them. Sometimes it's easier to not. Just like sometimes it's easier to keep a product separate as factors rather than to multiply it together. An example of this would be this 3 and 5 and 25 and 6. So the first thing I'm going to do, and this is counter to what I normally do. Normally I'd start flipping stuff because it's just easier to work with. I'm going to go ahead and I'm going to distribute this square through. And that's all I'm going to do. So I get 5x squared. And then 3 squared, remember that square comes down with the 3. It also comes down with this negative 1. But now we have a power to a power, so we multiply them. So this is going to be to the negative 2. I haven't done anything down below, so 25y cubed, and then 6y to the negative 2. Because I'm working within a fraction itself, I'm not as likely to continue in flipping stuff around. Personally, I would go ahead and I would use my product rule to work with the y's and the x's because I don't see a large advantage of doing otherwise. However, just to stay reasonably consistent, because all of this is in multiplication now, then I have a negative here that makes that go to the bottom. I have a negative here that makes that go to the top. Only the negative moves it from bottom to top and top to bottom. So this is going to give us 5x squared. We're going to have a times 3 in there. And then this y squared is going to come up from the bottom. In the denominator, I have 25y cubed times 6, and then we have this x squared coming down from the top. Now, any factor that occurs both in the numerator and the denominator can be canceled. It does not go. So many people want to make it just, it goes away. It's like magic. No, it doesn't go away. It becomes the identity in whatever that particular operation is. So because we're dealing with multiplication and division, the identity is 1. When I cancel x squared and x squared, anything divided by itself is 1. It doesn't go away, it becomes 1. The effect of it, however, if I multiply the 1 at the back end, 1 times anything is the anything. This is why people think it goes away. It doesn't go away, it becomes the identity. That's what we're hoping for. All right, so now I'm going to take care of the y's, and then I'm going to work with the numbers separately. So I have 3 y's on the bottom. I have 2 y's on the top. 2 y's on top will cancel out 2 y's on the bottom, leaving me with just a y to the first on the bottom. Now, switching colors so I don't get confused, I can go ahead and cancel out factors involving the numbers as well. 3 and 6 share a common factor of 3. Canceling the 3 leaves me a 1 and a 2. 5 and 25 share a common factor of 5. Canceling leaves me a 1 and a 5. Now, all I have to do is multiply everything through. So if I go through and I count all of the stuff I have left on the top, I have this 1, I have a 1, and I have a 1. All I have on top is a 1. All right, well, 1 times 1 is 1, times 1 is 1. In the denominator, I have a 5, a y, and a 2. The 5 and the 2 can combine, giving us a product of 10, and then the y to the first just becomes y. That is a simplified version. So all of these things can be used. I would have preferred up top, instead of going ahead and flipping everything at that, I just saw, oh, only x's are on top, only y's are on the bottom. Perfect, I can just use the product rule here, the very top rule, and say, okay, well, x squared times x to the negative 2, 2 plus negative 2 is 0. X to the 0 is 1. Okay, well, that would have cleaned it up. And I wouldn't have to do all the flipping. If you didn't go that route and you did the flipping route like I did, that's perfectly fine. You're going to end up with the same answer. The beautiful thing about this is that you can do it in almost any order that you wish, and you'll still get the same answer. You just have to follow the rules correctly. All right, on to the next one. So here we're dealing with a polynomial expression, but we're going to combine like terms to simplify it. On this particular problem, there were instructions that came along with it, and the instructions were to write the polynomial in descending order and state the degree and the type of each polynomial. For each, also state the leading coefficient. So first things first, we're going to bring everything together. All right, so I'm going to go through, and the way I do this is I go through and I pick out my highest degrees. Those are the terms that have the largest exponents. We only have an x. We don't have x's and y's and z's and that sort of thing. So we only have to worry about the exponent on x. So I have terms that have a 4. I have terms that have a 2. I have terms that have a 1. And I have terms that don't have any x's at all. The largest amount of x's that I have in any term is 4. So I'm going to select all of the x to the 4th terms to include their signs in front. If I don't see anything in front of the x, it's assumed to be 1. So really now I have 1 x to the 4th plus 3 x to the 4th. Okay, the coefficients are the numbers in front. When you add polynomials, you are only adding and subtracting those numbers. You have to have a common variable, the letter, and the letters have to have the exact same exponents, in this case 4. Once that's achieved, you only add or subtract the coefficients. So 1 plus 3 is 4, x to the 4th. You keep the x to the 4th. It does not become x to the 8th, because this counts the number of times you're multiplying, and to combine these, you are adding. The two operations are not the same. Once I've completed that, I usually just cross them out just to say, these are done, I'm moving on. Next, I find the next one. I'd be looking for x to the 3rd, but I don't see any. So since I don't have any of those, I skip it and I move on to x to the 2nd. I have that guy right there. He is the only one. So because of that, just bring him down. Then because my x squareds are done, cross that out. Now I work with all of my x terms here. This is going to give me a negative 2x, a positive 5x, and a positive x, which we know as 1. So I have, and I'm going to rearrange this, because again, the commutative property allows me to rearrange as long as I keep the sign with it. So when I ask this question, instead of negative 2 plus 5, I'm going to say, what is 5 minus 2? And it's 3, plus 1 for 4. So this is plus 4x. And those are done. And then finally, I have this minus 10. There's no other term that goes with it, so you just cram him onto the end. This is the simplified polynomial. Now, polynomials come in effectively 4 different styles, but they're just it's a way to quickly classify a polynomial. You do this by counting the number of terms. The terms are the ones separated by addition and subtraction. So this one has 1, 2, 3, 4 terms. Well, if it has 1 term, it's a monomial. If it has 2 terms, it's a binomial. If it has 3 terms, it's a trinomial. If it has 4 or more terms, we don't name it by its special nomial. It just becomes a normal polynomial. So this is just a polynomial. The degree of a term is the sum of all of the exponents of all of the variables in that term. In this case, we only have 1 variable, so the sum is the only exponent. So we have a degree 4 for the x to the 4th, a degree 2 for the x squared, a degree 1 for the x, because x to the 1st is x, and then we have a degree 0 for this 10. The negative 10 at the end is sometimes known as the constant because it has no variable associated with it. So one of the questions was, state the degree and type of the simplified polynomial. This is a polynomial. The degree of the polynomial is the same as the degree of the highest agreed term. So this is a degree 4 polynomial. In a sense, you can think of the degree of the polynomial as giving a number or a measurement of the complexity of the polynomial. The higher the number, the more complex it is. There are some limitations as to what we can and can't do with higher level polynomials, and that's for a whole other idea. So this has degree 4, sometimes known as a quartic. Not all that important, but it has some historical significance. Also, it says for each polynomial, state the leading coefficient. The leading coefficient plays some, well, to back up, when we're talking about mathematics, we want to do all of the things all at once if we can. So when we discuss the leading coefficient, you think, oh, that's stupid. Why would... Well, the leading coefficient tends to dominate whatever the polynomial is going to do. So because I know that the leading coefficient is 4, I can tell you something about its skinniness and its slope as you move kind of towards the outside. Because the leading coefficient is positive, I can also tell you that it's going to come down, it's going to do this, and then it's going to go up. It's going to look like a W. If it was negative, it would look like an M. It's going to have that look to it. And I can tell that just simply from whether or not that's positive or negative. That's why the importance of the leading coefficient. The leading coefficient is nothing more than the coefficient in the leading term, the term that has the highest degree. This is the leading coefficient. No matter where it occurs in fishy... Wow. Let's try spelling that correctly. Coefficient. Thank you, English. All right, so if the x to the 4th term was in the middle of all of this stuff, it wouldn't matter. The 4 is still the leading coefficient. It is the one that will dominate the look and feel of the polynomial. So we answered all of the questions. We identified it as, first of all, we simplified it. We identified it as a simple polynomial. It's not a monomial, trinomial, or binomial. We gave it a degree. It has a degree of 4 because that is the degree of the highest agreed term. And the leading coefficient is the coefficient of that highest term, which in this case is also 4. All right, moving on. If we're working with polynomials and we are adding or subtracting them, we are essentially combining like terms. How you do this is entirely up to you. I tend to teach it differently than I do it. So I'm gonna show you both ways, but it's gonna be a little bit easier to show the first way. If there's nothing out in front of a set of parentheses, it's a 1. That includes even if you're subtracting. In order to drop the parentheses and effectively make it look like the last problem, we have to distribute the thing out in front. When you're distributing, you're subtracting here, I highly recommend pulling the negative along with it and distributing that as well. The effect is, the second coefficient, the effect is distributing the -1 is going to change the sign of each one of those terms. So the 1 here is not going to change anything, so we're just going to have 2x to the 5th plus 3x cubed minus 2x squared plus x minus 5. Then I'm going to complete this by simply moving on with that negative 1 multiplying through. Negative 1 times 3 is a negative 3x to the 5th. Negative 1 times negative 2 is a positive 2x cubed. Negative 5x squared, negative 6x, and finally a positive 1. And then just like the last problem when we simplified that, I'm going to go through, I'm going to find the largest degree term, and I'm going to select all of those to include the sign in front. So I have 2 minus 3 is negative 1 x to the 5th. X to the 5th is done, so I cross those out to say I'm all done using them. Next I move on to x to the 4th, but there are none. Okay, move on to x to the 3rd. I have a 3x cubed, I have a plus 2x cubed, and so 3 plus 2 is plus 5x cubed. Notice again, we're adding only the coefficients and not doing anything with those common exponents. Next are the squareds. Gather up all of those. Negative 2 minus 5 is a negative 7x squared. And then we proceed with the x's. Again, if there's nothing in front of the x, it's assumed to be a 1. So this is 1 minus 6 for a negative 5x. And then we have minus 5 plus 1. So negative 5 plus 1 is a negative 4. So this is our answer. Okay, so if you like that, stop the video. Don't read the next thing. If you don't like that, or you're just looking for a different way to do it, go ahead and keep listening. This might appeal to you. If I rewrite this here, it helps if I'm doing this live because I use my fingers to do it. Now, the more complicated this gets, the more things you get put in front as far as the thing to distribute. So this coefficient would distribute through. If there turns out to be a 2, 3, 4, and you have something out back here, this first method is most likely going to be your best bet. You'll make less mistakes. If you're just adding or subtracting though, I don't find it too bad. This is going to depend a lot on mental math and your ability to keep things separate. So what I'm going to do is I'm going to circle all of my common terms here. So all of my x to the 5th terms get circled, and then I'm going to simply read the operation into it. So this is going to be 2x to the 5th minus 3x to the 5th. So 2 minus 3 is negative 1 x to the 5th. And I move right down the line just like that. So this is going to be 3 minus negative 2. But 3 minus negative 2 is like 3 plus 2. So that's going to be plus 5x cubed. Then negative 2 minus 5 is a negative 7x squared. Again, if you're in this and you're like, I don't know what you're doing, dude, then let it go. Do the other one. The other method will always work. This turns out to be somewhat faster once you get the hang of it. Realizing that we have a 1 here in front of this x, I have 1 minus 6. It's going to give me a negative 5x. And then I have negative 5 minus negative 1, which is really negative 5 plus 1 for negative 4. And if you check, all of them still end up the same thing. So what your preference is entirely up to you. Many instructors like to have you do one method at a time and then choose, or just simply do one method all the way through. Perfect, that's fine. I tend to be a little bit more free, which in some instances tends to really kind of screw my students because I'm not hammering them, hey, do only this, so that they only learn one thing. I want you to understand what's happening, because it's the understanding that allows you to control it. Once you have full control over it, it becomes yours forever. So I tend to read through unless it becomes overly complicated. You can certainly distribute through to kill all of the parentheses, and then just combine like terms as normal. Either way, doesn't really matter. There's probably lots more ways to do it out there too. You may have chosen to do this in a column format. That's perfectly fine. You can do it however you wish. All right, I hope this video helped you. Take care.